Welcome back, dear students. Now our topic is vestigial sideband modulation. Up to now we discussed about the three techniques: AM, DSBSC and SSBSC. In AM there are two disadvantages. One is power requirement is more, and another one is bandwidth requirement is more. In order to reduce the both, next development is DSBSC. In the DSBSC we suppress the actual carrier, we just sent only the two side bands. For this we achieve the lowest power saving by compared to AM. But in that also there are two side bands sends parallelly, which has symmetrical information. It means the both same information consists both for both the side bands. That's why we want to send any one single band including carrier suppression. That's why SSBSC incorporated. In that the bandwidth automatically reduced the in this technique including power. So a small disadvantages we discussed in previous session, that is that no lowest frequency components are not able to generate, are not able to transmit in SSBSC. That is the main problem. If any low frequency component are eliminated in this technique, that may cause a very big loss. That's why this technique is employed. The another technique, that is the vestigial sideband modulation. What is the main meaning of vestigial? Vestige means the avashesha, mean the meaning part. Mm, mm, what is the meaning? After the demolishing any content or any component, after the demolishing the remaining parts, it means the in our Sanskrit language that is called avasheshas. Okay, so this is the meaning of vestige. So in this vestigial sideband modulation we send a single sideband, but the vestige part of the another sideband also send along this, because if any lowest frequency components are in order to retrieve the lowest frequencies also, the either sidebands, not two sidebands, but the single sideband along with the vestige part of the another sideband. In this technique we send like that. This is the vestigial sideband modulation technique. Okay, so that is the discussion in this para. Vestigial sideband is a type of amplitude modulation in which one sideband is completely passed along the trace or tail or vestige of the other sideband. VSB is a compromise between SSB and DSBSC modulation. So this modulation technique also called compromising technique, because just like we compromise. In SSB we want to send only single sideband. In DSBSC we want to send two sidebands. But in this technique we don't send two sidebands, or we don't send either single sideband. This is the between these two sidebands. That was the compromise of the SSB and DSBSC. That's why it is called DSBSC, compromise of the DSBSC and SSB. So in SSB we send only one sideband. The bandwidth required to send SSB wave is FM. It means that is indicated by here the W. SSB is not appropriate way of modulation when the message signal contains the significant components at the extremely low frequencies. So in order to overcome this, VSB is used. Okay, here 1 minute. Here this is the frequency domain representation. the spectrum shown here as like this. The part either upper sideband or lower sideband along with another sideband, a part, some part of the other sideband will be sent along with the our wanted sideband. Okay. So, here the bandwidth is not in not 2 FM, it means here 2W in this notation, or not only W, it means FM. FM in the case of SSB, 2FM in the case of AM and DSB-SC. But in the case of VSB, bandwidth equal to FM plus frequency of vestige also. So, that is why W plus FE. So, FE is the width of the vestigial sideband, and similarly upper sideband is modified into the vestige. So, we want to send the lower sideband, the vestige part of the upper sideband will be added. If you want to send lower sideband, and then vice versa. Okay. So, this is the generation technique of generally VSB. There is a one point, important point, the vestigial sideband technique is generally used for transmit the TV signals, it means the video signals. Okay. So, in the TV broadcasting, the vestigial sideband technique is very, very useful. This is the generation technique of the modulator VSB modulation. Here VSB modulated block diagram is incorporated product modulator and sideband shaping filter. Here we observe the product modulator is already we know well known about this, because message signal into carrier signal, message signal and carrier signal will be multiplied here, and output is DSB-SC. Then this DSB-SC is further fed to the band pass filter in case of single sideband modulation technique. But in the case of vestigial sideband technique, the entire signal passed to the this filter allows only sideband shaping, means upper particular band pass, and also the another sideband, it means shaping means some part, it means the vestige part, it means the first half some frequency components. In the other sense, that words the other some frequency components in that particular lower sideband or upper sideband. So, that particular lower sideband and upper sideband frequency ranges, in that range there must be some frequency components are passed through here. That is why that is looks like here by drawing the physical by drawing the graphical representation. So, that is that's why it is called shaping. Okay. So, that is why it is called sideband shaping filter. So, sideband shaping filter allows the frequencies, which frequencies this allowed means it allows the only lower sideband or other upper sideband frequencies, as well as remaining sideband, the particular small frequency range components of the other sideband in form of vestige. Okay. So, this is the equation S of t equal to AC by 2 F minus FC plus FF plus FC into HF. Okay. It is the H is the Hilbert transform, means we are also discussed in for the Hilbert transform by the transforming techniques in the case of SSB SC techniques. Okay. Here this is the we decide, sorry, 1 minute. Here we observe this vestigial sideband modulated wave further fed to the received by the receiver by the for detection purpose we use the coherent model, coherent detector, that the signal is fed to the S of t is fed to the again for product modulator. If that product modulator carrier is supplied to the by local oscillator, the both the multiplication part V of t is present, S of t into cos 2 pi f c t. This is the multiplication of the vestigial modulated wave and the internal carrier wave. This signal further fed to the low pass filter. So, output of the low pass filter is the actual our desired message signal. This is the procedure of the generation and detection of the vestigial sideband technique. These are the step by step procedure for the equation derivation of the VSB. So, we just see a simple derivations in you see it on the our screen. You just follow that and note down that this is the equations. A simple equation means it, which means frequency f, here the f is the vestigious part. So, that part f minus fc fc minus fm and fc plus fm. Okay. So, it consists we conclude that this is the this output equation in frequency domain description. We conclude that the term one term is for sideband either lower or upper sideband, another term is for vestigious part. Okay. Similarly, you can understand like that. This is the spectrum diagram of the output of the product modulator. Okay. This spectrum of the VSB output product output modulator is for the both imaginary, if either ESB send or LSB send. That's why if you want send this part will be send as a vestigious. If you want to send this upper sideband, this part will be send as vestigious. Okay. This is the demodulated signal. That's demodulated signal here. This is the message signal. In above this is the message signal. These are the sidebands. Okay. In this output of the detector, this is the message signal what we retrieved successfully from the detector of the coherent detector of the VSB modulated wave. Okay. So, time domain description means this FC and FC, these are the frequency domain represented by applying the Fourier transform of our basic equation. This is the what is the DSB SC signal AC into m of t into cos 2 pi FCT, because m of t is the message signal, AC cos 2 pi FCT is the our carrier signal. So, the multiplication of these two are called DSBSC. It is a band pass signal and has in phase component only. Its low pass complex envelope is given by AC m of t. For the in case of VSB modulated wave, band pass signal is like this. These are the mathematical representations. You just follow and note down for better understanding and solve it. So, coming to the conclusion, the vestigial sideband transmission VSB SC is used to transmit video signal, I already told, which is large bandwidth signal containing very low and very high frequency components. So, the signal which is having large and low frequency signals contains very low and very high frequency signals, video signals. for sending those type of signals, we used vestigial sideband technique. Vestigial sideband also called VSB SC also. Here the carrier also subscribed. That's why VSB also VSB SC technique. We very low frequencies rise sidebands near to the carrier frequency. So I already discussed in the previous session, the lowest frequencies are creates the sidebands very closer to near 1 to 1 each. That's why that's why we eliminated in the SSBSC. But here those are very useful. We want to send also that also. That's why here we incorporated the vestigious part of the other sideband also. It is not possible to suppress one complete sideband. That's why so there is a practically there is a hurdle also for generating the SSB-SC, because a complete one sideband suppression is creates more loss to us. That's why we sent to the vestigious part of some part of that another sideband. Very low frequencies contain much of useful information. Any effect to complete suppress the one sideband would result phase distortion at these frequencies. This point is also similar to the we discussed already. Therefore, compromise has been made to suppress the part of sideband. That's why we compromise to DSBSC and SSB, because compromise means we తప్పని పరిస్థితి అంటాం కదా, అట్లా మనం చేయికి తప్పడం లేదనమాట. ఓకే, సో కాంప్రమైజ్ for compromise from the SSB and compromise from the DSBC. That's why we did not send two sidebands and did not send one single sideband. In the middle way we send a single band along with some vestige part. Okay, this is the modulation. We already see that the diagram. A product modulator, there are two inputs, one is carrier input and the message input. These two are fed to the sideband shaping filter. Okay, in the demodulation also the product modulator output fed to the low pass filter. Okay. So this is about the vestigial sideband. For this topic we complete the second unit also. Next, this is the up to the analog modulation and amplitude modulation. We successfully completed the amplitude modulation.